My intention is to do all of the problems, but if it takes too long, I'm not going to make this a 5-hour review. So let's get going. We'll just kind of start going one by one. So problem 1A. These are all going to be derivatives. So problem 1 is all find the derivative type problems. This is directly from the review posted on Canvas. So we have y equals 2x cubed over 7 minus 13x squared plus 4 over x to the negative fourth, not negative fourth, over x to the fourth minus pi. So I'm just going to rewrite this a little bit in order to make it a little easier to work with. So I haven't taken a derivative, I'm just rewriting. So we have 2/7 x cubed minus 13x squared, that'll stay. And then I'm going to rewrite this as 4x to the negative fourth. You could use quotient rule here, but it's just a really unnecessary time to use quotient rule. It's a lot faster if you just change it and then use product rule instead. Minus pi. Taking the derivative, using power rule, 2 times 3, that'll give you 6/7 x squared. 2 times 13 is 26x. 4 times negative 4 is negative 16. And then you're subtracting 1 from that exponent using power rule. So this would be negative 5. And then pi is just a number. So just as if this were like a 7 or an 8, the derivative of it will be 0. So I won't put it on there. And that will be your derivative. All right. 1b. We have f of x is equal to sine x times e to the tangent x. This will be a product rule problem, and it's also going to have chain rule involved. So we have an f and a g. Oops. Rule. Product rule, remember, is f prime g plus g prime f. So f prime, the derivative of sine, is going to be cosine x. And then g you'll leave alone. Plus the derivative of g. So the derivative of g is going to be the derivative of the exponent, and the derivative of the exponent is secant squared. Right? Times e raised to whatever it was raised to. So that's the derivative of e tangent x is secant squared x times e tan x, and then g prime, and then times f, which is sine x. So this bit right here was f prime, this was g, this was g prime, and this was f. If at any time you have any questions, please feel free to put them into that chat box. I am happy to answer any and all questions. I'm just going to keep on going until there are questions. But if there are, I will stop and we will answer any questions. All right. So for 1c, that's h of t equals cosine to the fourth of t all over ln of 2t minus 3. Now, it might help to rewrite this a little bit. So I'm going to go, let's see. I'm going to go ahead and write out the full quotient rule stuff here because we have to do quotient rule, since we have a quotient. So the top, I'm going to rewrite that as cosine of t raised to the 4th power. And I'm doing that so that I can really see where that chain rule comes in. So I'm going to take the 4 down, and then it's cosine t raised to the 3rd. So I'm using power rule there. And then times the derivative of the inside. So the derivative of the inside is negative sine of t. To rewrite this to make it a little more concise, the negative can come out front, so this can be negative 4, and then I could write cosine cubed of t sine t. That's just to rewrite it. You don't have to, but it just makes it a little easier to read. G is ln of 2t minus 3. Derivative of ln, it's the derivative of the inside, so 2, all over the inside. So 2 over 2t minus 3. For quotient rule, it's f prime g minus g prime f, all over g squared. So f prime was negative 4 cosine cubed of t sine t. G was ln of 2t minus 3 minus g prime is 2 over 2t minus 3. And f, you could choose either this version or this version. Since this version's prettier, I'm going to choose that version. So f is cosine to the 4th t all over g squared. So this would be ln of 2t minus 3 quantity squared. And that is your derivative. So it's a long one. It's kind of a messy one. This is a minus sign here, not a multiplication sign. But there it is. And I'm sorry if you hear some clicking in the background. My dog is in a cone right now, and he gets itchy, and then he itches his cone, and it makes noise. I guess I'll take a moment and ask, any questions so far? Okay. All right. We'll move on then. We'll do 1D. So for 1D, we have y equals x squared plus x plus 1 raised to the x. Now, because we have x in the exponent and we have it in the base, we have to use logarithmic differentiation here. Sorry, my other dog just ran into the room and I see you found a water bottle. Yeah, okay. Please don't chew that in here. Please go take that somewhere else to chew. So if it gets noisy in here, I apologize. Hold on just a moment. Let me pause myself and see if my husband can take him away. All right. Now they can have fun playing with the water bottle out there. All right, so you would take the ln of both sides. So you have ln y equals, and then ln on the other side as well, ln of x squared plus x plus 1 raised to the x. This x can come down in front now using our logarithm rules, and we haven't done any derivatives at this point. This is all just algebra. From here, we're going to do implicit differentiation on the left side, and on the right side, we're going to do product rule. So f is x, f prime is 1. G is ln of x squared plus x plus 1. G prime will be 2x plus 1. That's the derivative of the inside. All over the derivative, all over the inside. So it's the derivative of the inside all over the inside. So now that we're taking a derivative, at this point here, we're going to take a derivative. We're going to differentiate both sides. We get 1 over y, and then it's implicit differentiation here, so dy dx is equal to, using product rule here, it should be f prime g, so 1 times ln of x squared plus x plus 1, plus g prime, so 2x plus 1 over x squared plus x plus 1, times f. Right. We need to multiply both sides by y to get rid of the y on the left-hand side, because that's how logarithmic works. And we want to remember that y was originally defined up here. So we can replace that. We know y is equal to x squared plus x plus 1 raised to the x. So whenever you're doing logarithmic, you always have to make that replacement. And I like to put it up front. I like to take the y. I know it's multiplied over here, but I like to put it out front because that's who I am and that's what I like to do. So I would put the x squared plus x plus 1 raised to the x out front. And I'm just going to, it's not much simplification, but multiplying by 1 doesn't do anything here. So I'm just going to write ln x squared plus x plus 1 plus, and then this can multiply in. I mean, there's no reason not to. So you can make it 2x squared plus x in the numerator. You don't have to. No, don't have to do it. You can do it. It's up to you. Personal choices. But there is that. All right. So that was a logarithmic differentiation. And you had to do logarithmic there because you are in a situation where x is in the base and x is in the exponent. For 1e, we have f of z is equal to tan inverse of z to the 4th minus 2 minus 3 over the cubed root of z raised to the 4th. So I'm going to rewrite this before taking a derivative. I'm going to rewrite this guy in particular. So I'm not taking a derivative at this point. I'm just rewriting it. So this can be rewritten as 3, and then z raised to the, it's in the denominator, so we know the exponent's negative. And then it's always the power over the root. So it's negative 4/3. For the derivative, as a reminder, the derivative of tan inverse of x is 1 over 1 plus x squared. In this case, we're going to have to do, oh no, okay, there we go. It's like not letting me scroll down much. Okay, there we go. We're going to have to do chain rule here. So we're going to replace the x with the z to the 4th minus 2, and then we will multiply by the derivative of z to the 4th minus 2. So it's like you have this outside part, and his derivative would be 1 over 1 plus z to the 4th minus 2 squared. And then you have this inside part, and you're multiplying by his derivative, which would be 4z cubed. For this guy over here, negative 3 times negative 4/3 will become positive 4. Z to the negative 4/3 minus 1 is going to be negative 7/3. And you can rewrite that to be a little more pretty, but I'm just going to leave it right there. Questions on D or E before I move on to the next page? Okay. All right. We'll just keep moving along then. Okay. For a moment, I panicked, wondering if I had not clicked record. I have. We're good. I had a moment where I was like, oh no, did I not? All right. So for 1f is a doozy. So here we go. Let's see. It's f of t equals e to the t squared plus 3t times cosine of 2t plus 1 minus 4t plus 5 all over cotan t. All right. So we got some things going on because we're going to have to do product rule and we're going to have to do quotient rule. And it might help to kind of organize that work a little bit. So for our product rule, we have an f and a g. So f is equal to e t squared plus e raised to the t squared plus 3t. For that derivative, it's the derivative of the exponent, so 2t plus 3. Parentheses, very important here. And then it's e raised to the t squared plus 3t. So again, with e, it's the derivative of its exponent multiplied by the original thing. And then for g, the derivative of cosine 2t plus 1. You can do it in one of two ways. You can do the outside derivative and then multiply by the inside derivative. But because the inside derivative is going to be 2, I'm just going to put, well, I'll do it in 2 steps. Let's do it in 2 steps. So first of all, this is the original function. For the derivative, I'll do it in 2 steps here. So you have negative sine of 2t plus 1. That's the derivative of the outside. The derivative of the inside, derivative of 2t plus 1 is 2. So I was just going to move that 2 out front at first, but you know what? We'll do it in 2 steps there. Just kind of drawing a line between them to make them different. We have f and g over here. So for our quotient rule, we have f is equal to 4t plus 5. F prime is 4. G is equal to cotangent t. And here's how I remember these derivatives. I know that you have your notes in front of you and you don't need to necessarily have them memorized, but I know the derivative of sine, cosine, and tangent. Those ones I know off the top of my head. And I know this one is secant squared x. The closest thing, if you're thinking of cotangent and tangent, if tangent goes to secant, then cotangent ends up going to like the friend of secant, which is cosecant. So the derivative of cotan x, it becomes negative because all of the co-functions have negative derivatives. It becomes negative, and then it's cosecant squared x. So negative cosecant squared t in this case, because t is our variable. So for our derivative of f, we are going to have product rule first, so we'll have f prime g plus g prime f, plus then quotient rule for this guy. So that's f prime g minus g prime f all over g squared. F prime is 2t plus 3 e to the t squared plus 3t. G is cosine of 2t plus 1. So I have f prime g plus g prime. So negative 2 sine of 2t plus 1 and then f, which is e to the t squared plus 3t. Let's move it over because it's going to require more space than that. Plus, now doing this guy over here, f prime g. So f prime is 4, g is cotangent of t, minus g prime. So since g prime is negative, oops, what did I do there? Since g prime is negative, I'm just going to make this to a plus sign because they would cancel each other out. So plus cosecant squared t, and then f, which is 4t plus 5, all over g squared. So cotangent of t quantity squared. And that whole mess right there is your derivative. And typing that out was an ordeal. If you look at the answer key, it nearly didn't fit on one line. Unless, hold on here a second. Oh. I'm like looking at the answer key right now just to admire it. Because this was a minus sign here, because this was a minus between the product rules, this should be a minus right here, which means this should be a minus right here because it was a minus right up here in the very beginning. There you go, much better. So that one's a doozy. It's doable. It's just break it into parts. That's kind of the big thing with derivatives is just take it one step at a time. For number 1g, the derivative we're looking at, it's f of x equals the fifth root of x plus 5 cubed, 2x minus 9, x squared plus 2 raised to the fourth, x minus 3, 5x plus 7 squared. So normally I'm all about your creative mathematical freedom to do whatever you want, however you want. But for this one, if you tried to do quotient product ridiculous chain rule here, oh my goodness, it's going to look awful. I'm not going to go through it doing quotient chain product rule. That's absurd. I'm not going to do it. I'm going to use logarithmic differentiation here because that's the only way that really makes sense. So I'm going to pretend like this was a y, and I'm going to take the natural log on both sides. So I'm going to kind of cheat here and write my ln's right here, taking the natural log on both sides. Now, this right here is the same thing as the whole thing being raised to the 1/5 power. I normally don't do this in steps, but I am going to do it in steps this time. So I could bring down the 1/5 power to begin with. So that's essentially, when I took the ln here, this whole big fifth root, it's taking down that fifth root part first. And then I'm still going to do algebra. I haven't done any calculus yet, and I'm not going to do it for the next step. I'm going to leave the ln y alone, right? And then I'm going to break up this mess here. So I have ln y is equal to 1/5. That'll stay on the outside. All right. And then everything up here, if it's in the numerator, it's going to be a positive and all the exponents will come down. And if it's in the denominator, it'll get a negative in front of it. So first we have 3 ln of x plus 5 plus ln of 2x minus 9 plus 4 ln of x squared plus 2. For the denominator, we have minus ln of x minus 3, because it's in the denominator, so it's minus, then minus 2 ln of 5x plus 7. Now we're going to take a derivative. From this step, we're going to differentiate both sides. Now that it's all algebraic out. On the left side, we have chain rule, so we'll do, or implicit differentiation, chain rule. So we have 1 over y dy dx. Then this 1/5 right here, I'm going to let him sit out front, and I'm going to take these derivatives. Right. So we have 3 times, and then for all the ln's, it's the derivative of the inside over the inside. The derivative of x plus 5 is 1 over x plus 5. The derivative of 2x minus 9 is 2 over 2x minus 9. Plus 4 times the derivative of x squared is 2x, or x squared plus 2 is 2x. Then it's all over x squared plus 2. Minus the derivative of x minus 3 is 1 over x minus 3. Minus 2 times the derivative of 5x plus 7 is 5 over 5x plus 7. The combining that I'm going to do in the next step, I am going to multiply these numerators together just because it makes it a little less writing for me. So I'm going to do that, and I'm additionally going to get that y to cancel out. So I'm going to multiply by y here, remembering that y was this giant thing up here, right? Y is this whole thing. So I have dy dx equals this 1/5 I'm going to put up front, and then the y I'm going to put next. So the 5th root of this mess right here. So just as a reminder, don't you start barking, don't do it. The y is right there. And now I'm going to put all of this stuff. So we have 3 over x plus 5 plus 2 over 2x minus 9 plus 8x over x squared plus 2 minus 1 over x minus 3 minus 10 over 5x plus 7. Whew. So is it a lot? Yes, it is a lot, but it does come out. It comes out okay, and it comes out okay. Since that one's a big problem, I'll take a moment. Are there any questions? That one's a hefty one. Okay, no questions so far, I'm assuming. If you do, feel free to type them in there. Okay, so we'll do 1h then. For this guy, we have y equals, and then it's sine inverse of theta cubed raised to the 4th power minus the square root of theta to the 7th power. The only rewriting I'm going to do here is I'm just going to rewrite this guy. So I'll leave the first part alone. But this is theta raised to the 1/7 power. For the derivative, there's a lot of layers here. The most outer layer is this whole thing here, including this 4th power. Maybe I should have done that down here. This whole thing here, including this fourth power. So we would bring the 4 down. It's going to be power rule. 4 sine inverse of theta cubed. And then we lower the exponent. So that's the outside. And then we have a middle layer. And as a reminder, the derivative of sine inverse is going to be 1 over the square root of 1 minus x squared. But instead of x, obviously we have theta cubed. So we're going to end up with a theta cubed squared there. So times 1 over the square root of 1 minus theta cubed squared. And then it's the derivative of the most inside, which is the theta cubed part. The derivative of theta cubed would be 3 theta squared. Minus, and then the last part is just 1/7 theta to the negative 6/7. So it's a multi-layered one. It's not one layer, it's multiple layers. But not awful, hopefully. You just have to kind of get used to it. For 1i, this one you can use logarithmic or you can use quotient rule. I put the answers for either in the answer key. I'm fairly certain at least that I put both answers in the answer key. I will take whoever gives me the first response on whether you want to do logarithmic or quotient here. Whatever I see first. I like logarithmic. All right, let's do logarithmic here then. So we're going to pretend this is a y, and we're going to take the natural log on both sides. So we have ln y is equal to this first part here. The radical is the same thing as being raised to the 1/3 power. So maybe what I'll write over here is that this is the same as x squared plus 2x plus 1 raised to the 4th power, all raised to the 1/3. But then these can multiply. So it's actually x squared plus 2x plus 1 raised to the 4/3 power. So when I'm taking the ln here, the 4/3 power will come down. So we have 4/3 ln of x squared plus 2x plus 1 plus, not plus, minus, because this is in the denominator, pi comes down. Pi is just a number, so pi ln of 2x plus 5. Now we're going to differentiate now that we've done the log stuff. So we have ln y equals 4/3 times the derivative of the inside is 2x plus 2 all over the inside, which is x squared plus 2x plus 1, minus pi times the derivative of the inside is 2 all over 2x plus 5. And I forgot something. I didn't take the derivative of ln y. That was what I forgot there. Derivative of ln y is 1 over y dy dx. And then you're good to multiply by y on both sides, remembering that y is this entire thing that you began with. So you get dy dx is equal to, I'm going to put the y part first, so the cubed root of x squared plus 2x plus 1 raised to the 4th power all over 2x plus 5 raised to the pi. And then this derivative. So I'm not going to fully combine the first one together. I'm just going to kind of combine it like this. Don't need to, but little bit easier. And then I'll make this one 2 pi just because it's less writing. And bam, you got yourself a derivative. So either way, we'll work on that one. All right. 1j. So j is k of z is equal to z times sine of ln z. I'm just going to kind of skip some parentheses there to make it a little easier to read, plus cosine of ln z is the original. This is going to take product and rule, and it's also going to take some chain rule in there. So we have f, we have g. F is z, and the derivative of z is just going to be 1. That part's nice. G is sine of ln z plus cosine of ln z. So for this derivative, the outside function here is sine. So the derivative of sine is cosine, and leave the inside alone, cosine of ln z. And then the inside is ln z. The derivative of ln z is 1 over z. Actually, this would be a plus, but because cosine's derivative is negative sine, I'm just going to write minus sine of ln z. And then the derivative of the inside is 1 over z. So k prime of z is going to be f prime g plus g prime f. F prime is 1. I'm not going to write that. And then g is sine of ln z plus cosine of ln z. Plus g prime is cosine ln z times 1 over z minus sine of ln z times 1 over z. So that's the g prime part, and then f is z. Now, if you wanted to be really fancy here, something you could do, because these guys both have a 1 over z in them, if you really wanted to, if you distribute the z would just go on top of the 1 over z and cancel itself out. So this actually simplifies really nicely because you start with, right, these guys will come down. So you have sine ln z plus cosine ln z. And then this guy here, because these 1 over z's would cancel if you distributed, you end up with plus cosine ln z minus sine ln z. I only mention this because it's a fun simplification, because then these signs cancel because you have plus and minus, and then you just have 2 of the cosine ln z's. So it actually comes out to be 2 cosine of ln z, which is pretty amazing. That the whole derivative of that nasty thing comes out to be 2 cosine ln z. Pretty spectacular. Oof. Questions on part J? Right? It's pretty cool. It's pretty cool. Is it tedious? Maybe. But it is pretty cool. Some fun stuff in there. I'm glad you think that. All right, so now 1k. Y equals 1 over x squared plus the square root of tangent x plus 4 to the x. Now here's the thing. You can do quotient rule here. That's totally fine. And in the answer key, I do both. I do quotient rule, and then I also do using a trick. Because there's nothing in the numerator here, I could really just rewrite this as x squared plus, I'm going to take this time to rewrite him as an exponent. I could write it as raised to the negative 1 power. I can do that because there's only there's only a 1 in the numerator, and then the rest is just the denominator, and it's just all being raised to the negative 1. So you can be tricky here and do that, and then you can have some super fun chain rule. So you have the outside, which includes this negative 1. So you bring the negative 1 down, negative, leave the inside alone. And then negative 1 minus 1 is negative 2. I should have done that in purple. This whole thing right here should have been in purple. And then it's the derivative of the inside. So 2x plus, now this thing right here has its own inside, right? So we have to take the derivative of the outside part first with this 1/2. So plus 1/2 tangent x plus 4x, 4 raised to the x, that is, raised to the negative 1/2. And then the derivative of the inside, the derivative of tangent x plus 4x. If you remember the derivative of a raised to the x, I think the way that we wrote it was ln a times a to the x, which is the same thing as doing a to the x ln a, whichever makes your heart most happy. I think this one makes me most happy here. I'm just like, yeah, so the way that we wrote it on the notes was this way, but I mean, multiplication is commutative, so you can move that around. So multiplied by the derivative of tangent x is secant squared x. The derivative of 4 to the x, it's like this is a 4 instead of an a. So this would be 4 to the x ln 4. And that would be your derivative. Nasty, but doable. So once again, if you rewrite it, then you can take the exponent down, and then you got power rule. Then it's the derivative of the inside. The x squared part's nice and easy. That one's fine. And then this part right here requires another chain rule where you take the outside part, bring them 1/2 down, subtract 1, and then the derivative of tangent x plus 4x. And parentheses are really important in that because if your parentheses get mixed up, it becomes a different meaning. Whew. So I think I'm going to move, when I move to the next page, I think I'm going to move to the next page for the next problem, just because the next problem has a few pieces in it. So let's see. 1L. That's an L, not an E. 1L. It's f of t equals t squared times secant of 3t times e to the square root t. You're going to have to do some product rule. So starting out, you have to kind of separate this into a a big F, and G. So you have to lump it somehow. You could lump these guys together, or you could lump these guys together. You could even lump these two together and put the other one as the F or G. But I'm going to lump t squared secant 3t together, and then e square root t will be it's on its own. So we have F is equal to t squared times secant of 3t. And to do this derivative, we need to do product rule. So product rule here, F is going to be t squared. F prime is going to be 2t. G is secant of 3t. The derivative of secant is going to be secant 3t tangent 3t. And then the derivative of the inside, derivative of 3t is 3. So I'm just going to put that 3 out front there. So 3 secant 3t tangent 3t, because 3t was on the inside. So F prime is going to be product rule here, F prime G plus G prime F. So we have 2t, and then G is secant of 3t, plus G prime, so 3 secant 3t tangent 3t times F, which is t squared. I personally like to see my t's right out front, so I'm going to move my t's out front when I rewrite them. So that's F prime. G, going back up to here, all the way up, G was E raised to the t raised to the 1/2 power. So his derivative, the derivative of the exponent is 1/2 t to the negative 1/2. And then E raised to the, it's okay to write them as square root t this time. Or you could write it as t raised to the 1/2 power would work too. So the derivative of f prime of t, looking at these guys now, f prime g plus g prime f. F prime, 2t secant 3t plus 3, and then I'm moving that t squared out front, 3t squared, secant of 3t tangent 3t. So it's f prime. G is secant 3t plus g prime. Whoa, hold on. Whoa, okay, hold on. Wait. What did I do? What did I do here? I confused myself. Wait. Oh, I see how I confused myself. All right. Let me unconfuse myself. So this should have been like 2t secant 3t, because this is f prime g. So this is f prime g, and then plus g prime f. Not f. This is not f. This part shouldn't be here. Sometimes you just start going. There we go. That's f. Woof. Got that figured out. All right. So once again, let's just... Oh, no, I just confused myself more, and I'm confusing everybody now. Let me just take a moment and breathe. I confused everybody. Back to the drawing board, everybody. Just kidding. But also not kidding. Back to the drawing board, everybody. I was looking at this, but I should be looking at these guys right here. Sorry about that. F prime, G prime. Those are the ones I want to be looking at. So F prime was 2t secant 3t plus 3 secant 3. It was right the first time. 3 secant t tangent 3t times t squared. Okay, so that whole thing is f prime. Bam, f prime. And then g right here, who is also the same thing as e raised to the square root t. Sorry to confuse everybody. F prime g plus g prime is 1/2 t to the negative 1/2 times e raised to the square root t. And then f, which is t squared secant 3t. Oof. So it's easy on those ones to kind of get, like you said, like you just saw, kind of confused with your own work. So it's important to go back, check, and make sure you're actually putting the right derivatives in the right place. Because even if you have all the right pieces, which we did, we had all the right pieces here, you can still go wrong in putting it all together if you start looking back at other stuff that you weren't working with. But there it is in all of its beauty. Okay, 4 more derivatives. And then there's other problems which are also mostly derivatives. 1m. Once again, you are not obligated to stick around for this entire thing if you don't want to. I know it's a bit on the tedious side. I'm hoping it'll kind of pick up after this first part is like there's a lot there. So I'm hoping it'll kind of pick up after that. We'll see. 1m. We have y equals x raised to the square root of x, which I'm going to rewrite as x raised to the x raised to the 1/2 power. Once again, we have a situation with x in the base and x in the exponent, which means you have to use logarithmic differentiation here. So you do have to use logarithmic, log diff. So ln y equals ln of x raised to the x raised to the 1/2. If it makes more sense here, which it might to you, to leave it as the square root x for a moment, that's fine, because it can get a bit confusing because this square root x needs to come down in front. And if you don't want to get confused about the 1/2, it might help to keep it like this for a moment. So you have ln y equals square root x, ln x. And now you can rewrite that. So it's x to the 1/2 ln x. This is going to require product rule. So we have an f, we have a g. F is x to the 1/2. F prime is 1/2 x to the negative 1/2. G is ln x. G prime is 1 over x. So when we differentiate both sides, so d dx, when we differentiate both sides, on the left we have 1 over y dy dx is equal to f prime, so 1/2 x to the negative 1/2. G is ln x, plus g prime is 1 over x, and then f is x to the 1/2. Multiplying both sides by y, and y is right here, you get dy dx is equal to x raised to the square root x, so I'm putting the y part first. Then we have 1/2 x to the negative 1/2 ln x plus x to the 1/2 over x. That could be simplified, but for the moment I just don't feel like doing it, so I'm not going to simplify it. I'm just going to leave it like this. If you're wondering how this simplifies, it would become x to the negative 1/2, but it's just, I'm not going to do it. We've done enough. So that is logarithmic differentiation on that one. And that's whenever you have an x in the base and an x in the exponent. And if at any time you need me to go back a slide, feel free to mention it. I'm happy to go back. So we have 1 over n. And someone said, I like the limits unit, but I do not like derivatives at all. Oh no, I think you'll like it. You just got to give it a chance. I think the problem with derivatives is there gets to be a lot. There's a lot to keep track of. And especially as they get more and more complicated, it's like there's a lot of bookkeeping to do. But the more and more you do them, the more and more you'll feel sort of like you did with limits, where you're like, oh, that's kind of neat. That's kind of cool. That's like, feeling kind of tricky there. So I think if you just got to give it a chance to seep in, and I think you'll like it. I hope. Derivatives don't stop following you, unfortunately. Derivatives exist for the rest of math. It will. You'll like it. You just got to keep doing it and telling yourself you like it, and eventually you'll like it. Just true of anything, right? Just tell yourself you like it. It's like spinach. I tell myself I like spinach so that I like spinach. Just kidding, that doesn't work because I do not like spinach. But I hope for you that derivatives come through and that you enjoy them. All right, 1n is this beauty. Clearly, I'm going to rewrite this before moving forward. So I have this is raised to the 1/2 power, and this is raised to the 1/2 power. So a lot of chain rule to happen here. Derivative part. For the derivative of the outside, we're taking that 1/2 power down. So we have 1/2, and then this is just power rule, so we'll leave the inside alone. Then we subtract 1 off the exponent. Next, we have this part in here. The derivative of 1 is just 0, right? So I don't really even need to write him. Instead, I can just focus on this piece because, I don't need to do, if his derivative is 0, it's just going to go away. So instead, I'm really focusing on this piece. I can bring down his exponent because we're doing chain rule again. So we have 1/2, leave the inside alone, 1 plus ln x, and then subtracting 1 off the exponent, so negative 1/2. And then the derivative of the inside. Derivative of the inside, derivative of 1 is 0, derivative of ln x is 1 over x. And there it is. And that could technically be simplified, but I'm not going to do that. That's not what I'm going to do today. More than I hope to do. But there it is. It's just a process. It's just a process of getting all your stuff together and then making sure you have all the layers taken care of. Chain rule is the hardest part. This is a 1-0. We are very nearly done with these derivatives. So we have tan inverse of W EW. So with tan inverse, the derivative of tan inverse of x was 1 over 1 plus x squared. In the case where you have stuff in here instead of an x, right, it just becomes whatever that stuff is squared times the derivative of whatever that inside stuff is. In our case, we have w e to the w. So this would be w e to the w, and then the derivative of w e to the w. So we are going to need the derivative of w e to the w. That's going to happen. And we can kind of do that down here since we know it's going to happen. We can do our, this is like, this is our f This is our G. F is W. F prime is 1. G is e to the W, and G prime is e to the W. So the derivative, ddw, I guess, the derivative of W e to the W is F prime G, 1 times e to the W, plus G prime is e to the W, G prime F. So W times e to the W. So G prime of W, no, I'm sorry, G prime of W, derivative of the outside is going to be this green part over here. So we have 1 over 1 plus W e to the W squared. And then it's the derivative of W e to the W. So this is this stuff right down here. E to the W plus W e to the W. Layers. Okay, one last one from problem 1, and then problem 1 is over. So problem 1p, just more chain rule. Y equals sine of ln of x cubed plus e to the x. So this is just a bunch of chain rule. So the outside is sine. So for y prime, the derivative of sine is cosine. So cosine, leave the inside alone. Leave the inside alone. Next layer is ln, right? And the nice thing with ln is we already kind of take care of chain rule, so we don't really have to do 3 layers here because we take care of chain rule by doing the derivative of the inside over the inside. So we have the derivative of the inside is 3x squared plus e to the x. Over the inside is x cubed plus e to the x. And again, we don't have to do another chain rule here because the chain rule we would be doing is this part right here that we already took care of. And that's that for 1p. That's it for 1. Whew. Any questions at all on any of the parts A through P on problem 1? And you should know this from the first review. The tests are not as long as the review. That would be ridiculous, and I would never grade something that long. I don't want to do that. You don't want to do that. Nobody wants to do that. So just so you know, the test will not be as long as the review. The review is meant to help you study. It's not meant to be an actual test. All right. Then I guess we'll move on to 2. So these ones are going to be finding higher order derivatives. So this one, you're given a function. This is e raised to the x squared plus cosine of negative 3x. And you're asked to find, in this case, f triple prime of x. F triple prime. So this is just a process. We start with our first derivative, which is f prime. For e to the x squared, it's the derivative of the exponent. So that'll be derivative of x squared is 2x, and then e to the x squared. For the next part, plus cosine's derivative is negative sine, and then the derivative of the inside is negative 3. When you're taking higher order derivatives, it is always a good idea to simplify before moving to the next step. So like this part's fine, 2x e to the x squared. I can leave him alone. But here we have a negative times a negative, so those would just become positive, and I can move the 3 out front. So this would be plus 3 sine negative 3x. And keeping track of your negatives is important. And then we go in for the second derivative. Now we're going to have to do some chain rule. Not chain rule, product rule is what I meant to say. So f is 2x, f prime is 2. G is e to the x squared, which we already did his derivative before. It's 2x e to the x squared. So f double prime, the second derivative, f prime g, so 2 e to the x squared, plus g prime, so 2x e to the x squared, times f, which is 2x, f prime g, and then we take the derivative of this guy. So plus 3, the derivative of sine is cosine, and then the derivative of the inside is negative 3. So we're going to simplify before moving forward once again, because we have to find the third derivative, and it's really important to simplify. So here, 2 times 2 is 4, and then x times x is x squared. So you have 2 e to the x squared plus 4 x squared e to the x squared. Then we have 3 times negative 3. So that's just going to become minus 9 in front. So minus 9 cosine of negative 3x. And we go in for our third derivative. Once again, doing product rule on this guy here. Maybe I'll use a different color this time. This one is going to require product rule. So f is 4x squared. F prime is 8x. G is e to the x squared. G prime is 2x e to the x squared. Oh no, can I not scroll up anymore? It's okay. We'll have enough room here. It'll be fine. So f triple prime. This guy comes first. So the derivative here, the 2 is out front. And then the derivative of e to the x squared is 2x e to the x squared. Plus, now it's time for the product rule. So plus f prime g, so f prime, and then g, plus g prime, so 2x e to the x squared, f times 4x squared. Then it's time for the derivative of this negative 9 cosine negative 3x. So it's negative 9. The derivative of cosine is negative sine. And the derivative of negative 3x is negative 3. You don't have to simplify this, but it's nice to. So I am going to. So 2 times 2 is 4. So we have 4x e to the x squared. Next we have plus 8x e to the x squared. Technically, these guys right here could be combined together because they both are the same. They're like terms. So you could make it 12x, but I'm not going to go that far. Plus 4 and 2 multiply together to give me 8. And then x times x squared is x cubed. So we have 8x cubed e to the x squared. Then there's a lot of negatives here. And this one actually caught me off guard. I got this wrong the first time because I was not careful with my negatives. There's 3 negatives here. There's a negative, a negative, and a negative. And a negative times a negative times a negative is a negative. So this is minus 3 times 9 is 27 sine of negative 3x. Let's see, let's make sure that I'm going to check this against the answer. In the answer key, make sure that I caught all the negatives. Yes, I caught all the negatives. So in the answer key, the 4x and the 8x e to the x squared are combined together, but I'm not going to do that. So okay, moving on to 2b. We have y equals ln of 2x cubed plus 5x minus 9, and we are asked to find the second derivative of this function. So we'll go with the first derivative, y prime. For this one, we're just looking at ln, right? So derivative of the inside is 6x squared plus 5 over the inside, 2x cubed plus 5x minus 9. No big deal there. That's your first derivative. For your second derivative, quotient rule, right? So you have an f and a g. F is 6x squared plus 5. F prime is 12x. G is 2x cubed plus 5x minus 9. G prime is 6x squared plus 5. So y double prime, which is the same thing as this, same thing. Quotient rule is f prime g minus g prime f all over g squared. So f prime is 12x. G is 2x cubed plus 5x minus 9. Minus g prime, 6x squared plus 5, times f, which is also 6x squared plus 5, all over g squared, 2x cubed plus 5x minus 9, quantity squared. Can be simplified, but I'm not going to bother. So there's that. So that one's actually, I would say, a little easier. Finding the third derivative oftentimes comes down to some nastiness because you end up having product rule on multiple steps, and then there's simplification that has to be done. So the third derivative tends to be the one that's most nasty, unless you're talking about polynomials, in which case polynomials tend to be easier to deal with. So we'll look at 2c. We have h of t is equal to sine of t squared e to the t, and we are asked to find h double prime. So we'll find the first derivative here. The derivative of the outside will be cosine, and then leave the inside alone, t squared e to the t. Product rule on this with f and g. I'm just going to kind of do this one quickly. So it's f prime, so 2t, and then g, e to the t, plus g prime is e to the t, and then times f, which is t squared. Now, I could distribute this out, but it's just going to kind of make it a little bit messier. So instead of distributing this out, I am just going to, I'm just going to leave it the way it is. One thing I want to mention, though, is that this whole thing here is the derivative of t squared e to the t. And that's important because it's going to come back. So sometimes you can use this circular reasoning. And I just moved the t squared out front. Sometimes you can use this circular reasoning in these problems. So I'm going to have to find the derivative of t squared e to the t again. And I've already found it. So I want to use that again. I don't want to forget about that. So for the second derivative, we are looking at product rule. f is cosine of t squared e to the t. F prime will be negative sine t squared e to the t, and then it's the derivative of t squared e to the t, which we already found. It's right here. 2t e to the t plus t squared e to the t. For g, you're going to have to do some chain rule. So this guy right here, when you go to do product rule on this guy is this. So we can take care of that. But you will have to do another product rule here. So the original is 2t e to the t plus t squared e to the t. The derivative f prime is 2, g is e to the t, plus g prime is e to the t times f is 2t. And then this derivative, so that's the derivative of that. This derivative is right up here. So plus 2t e to the t plus t squared e to the t. And this can actually combine together a little bit because these are both 2t e to the t's. So these together would make 4t e to the t because there's 4 of them. So you could make your g prime a little bit nicer. 2 e to the t plus 4t e to the t plus t squared e to the t. And then taking this product, the big product rule up here, you get h double prime of t is equal to f prime, so negative sine of t squared e to the t times 2t e to the t plus t squared e to the t. That's f prime. G, so 2t e to the t plus t squared e to the t. Plus g prime, right down here, 2 e to the t plus 4t e to the t plus t squared e to the t. This is g prime. And then f is right here. So cosine t squared e to the t. And that, my friends, is the beautiful derivative. This one is it's just tedious. All right, it takes time. It's tedious. There's a lot of pieces that float around. Finding ways to organize your work is most important. If you can color code, I find that color coding helps a lot. Okay, cool. So then, last part of 2D. This one is y equals x to the x, and you want to find y double prime. And the hint that's given is that you've already found the derivative of x to the x. And I'll just kind of go through that derivative as we get there. So this is a situation, we have x in the base, x in the exponent. You are going to have to use logarithmic. So you have ln y equals, this x can come down in front. So you have x ln x. When you go to take this derivative, you have f and g. F is x, f prime is 1, g is ln x, g prime is 1 over x. So implicit differentiation, 1 over y dy dx. F prime is 1, I'm not going to write that, times g, which is ln x. plus g prime is 1 over x times f, which is x. But here's the fun thing. 1 over x times x is just 1. So you can just write 1 there. I mean, you can write 1 over x times x as well, but why do that when you don't have to? All right, and this is the first derivative we're finding because we do have to find y double prime here. So we're multiplying by y, and y is x to the x. Maybe I should have wrote that we're finding the first derivative. So you get dy dx, which is the same thing as y prime, is equal to, we have x to the x, ln x plus 1. Now, the hint says, hint, you've already found the derivative of x to the x. So when you go to do this second derivative, you have to do product rule here, right? You have to do f and you have to do g. But this whole thing here is the derivative. The derivative of x to the x is x to the x ln x plus 1. That was the derivative you found in the first place. So when you go to do quotient product rule here, you don't have to find x to the x again. You don't have to do that. So for y double prime, for f you have x to the x, f prime, like I said, you've already found that, x to the x ln x plus 1. G is ln x plus 1, and that derivative is just 1 over x. So for y double prime, f prime g, x to the x, I'm going to have to move this, x to the x, ln x plus 1, that's f prime. G is ln x plus 1, plus g prime is 1 over x, and f is x to the x. And there's your derivative. So it's actually not as bad because you've already found this derivative. Knowing that you found this derivative is really important because it's complicated, right? It's the more complicated one to do. Once you've found it, then you can use it when you go to do product rule down here, and then it's a lot easier. Can I answer any questions on that one? Okay. So because I'm lazy, just going to do that so I don't have to rewrite it. All right, suppose that f is a differentiable function such that f of 5 equals -2, and the line tangent to f at x equals 5 is perpendicular to 3x minus 3y equals 5. Find the x-intercept of this tangent line. All right, so we have a function f, and we want to find the x-intercept of a tangent line. When it all comes down to it, that's what we're looking at. We're looking at finding the x-intercept of a tangent line. So our first step, step 1, is find tangent line. To find a tangent line, and it's really important that you break things down into these steps. To find the tangent line, you need an x value, a y value, and you need a slope. The x value is given to us. They told us 5. The y value comes from plugging 5 into the original function, which means this is from f of 5, which was actually given to us right here. They told us f of 5 was -2. Now, we're normally able to find m by doing f prime of 5, but we don't have any way of finding this. Like, how? We don't have a function. There's not really anything we can do here because we don't have that information. So that's not going to do it here. We have to go back and figure out what is going on. We were told that this tangent line is perpendicular to 3x minus 6y equals 5, which we can rewrite as negative 6y equals negative 3x plus 5. Y equals negative 3 divided by negative 6 is 1/2 x minus 5/6. It's perpendicular to this line. Being perpendicular to this line means that our slope should be the opposite reciprocal of it. So if it's positive, it becomes negative, and then you flip the fraction upside down. The slope is negative 2. So our tangent line, y minus y1 equals m times x minus x1. So we have y plus 2, because negative 2, equals m is negative 2, and then x1 is 5. And if you want, you can solve for x here. So I'm not solve for x, solve for y here. So you can write it in mx plus b form. So plus 10 minus 2 plus 8. But what we wanted was the x-intercept of that line. So it's 2 steps right here. The second step here, step 2, find the x-intercept. And if you think back to your Math 126 class or Math 95E, that's when you let y equal 0 and solve for x. So 0 is equal to negative 2x plus 8. 2x is equal to 8. X is equal to 4. So the x-intercept is at 4, 0. So multiple steps there. First step, find the tangent line using the fact that it's perpendicular to the line that they gave us. And then from there, you're able to set y equal to 0 and find the x-intercept. So that is that on that one. All right. So for number 4, you're going to be finding equations of tangent lines at a specific point. So let me just write down that this is find tangent line at x value given. So for 4a, you are given f of x is equal to secant of pi over 4 x squared, and you're given x is equal to 1. Once again, the information that you need when you want to find a tangent line, you need an x1, which is given to you. It's 1. You need y1, and that comes from plugging in your x value to the original function here. So this is secant of pi over 4 times 1 squared. Right? Let's see. Secant of pi over 4. So secant of pi over 4, that's 1 over cosine of pi over 4. So that would be 1 over root 2 over 2, which would be 2 over root 2, which I think simplifies down to root 2. You could use your calculator and be a lot faster at this. I'm fairly certain that simplifies down to root 2. I'm just going to not trust myself for a moment, though. Yes, we good. Square root 2. Yay. And you need a slope. For that, you're taking the x value and plugging it into the derivative. So we need to find the derivative. The derivative of secant is secant tangent. So leave the inside alone. Secant pi over 4 x squared. Tangent pi over 4 x squared. And then it's the derivative of the inside, so the derivative of pi over 4 x squared. So you have pi over 4, and then the derivative of x squared is 2x. I can now plug in 1 to this to get my slope. So I have secant of pi over 4. 1 squared is just going to be 1, so I'm just not going to write it. Secant of pi over 4 times tangent of pi over 4 times pi over 4 times 2 times 1. Just plugging 1 into that derivative. Secant of pi over 4 is square root of 2. Tangent of pi over 4 is 1. And then we have pi over 4 times 2. Believe it or not, this simplifies just the teeniest, tiniest bit to square root of 2 pi over 2. So our line is y minus y1 equals m times x minus x1. y1 is square root 2. M is square root 2 pi over 2. x1 is 1. Normally I would put these into y-intercept form, but this is kind of nasty, so I'm just going to leave this one alone because he's really, I don't like the way he looks. So I'm going to leave him alone. All right, for 4b, you are given y equals x minus 1 over x plus 1 quantity squared, and you're actually given the point 0, 1 here. So you're actually given both the x value and the y value here. So once again, for a tangent line, you need an x value, a y value, and a slope. The x value is 0, and then the y value you don't even have to find because it was given to you, so it's 1. For m, you do need to find the derivative and then plug the x value in. So we need to find the derivative of this guy. For y prime, chain rule, so the derivative of the outside. And then the derivative of the inside is going to require quotient rule. But it's pretty nice looking. So we have f prime g, 1 times x plus 1, minus g prime f, so 1 times x minus 1, all over x plus 1 quantity squared. And here's why this is convenient. Oh, no, just kidding. I thought it was going to be 1. It was going to be really convenient. We can simplify this a little bit. It's not going to be. If it was 1, it would be really convenient because then 1 minus 1 is 0, but our x value is 0, so it's not as convenient. I'm just going to simplify a tiny bit. So y prime is equal to 2 times x minus 1 over x plus 1. And then here you would have x minus x, so the x's cancel. Negative 1 times negative 1, negative is positive 1, so 1 plus 1 is 2. So 2 over x plus 1 quantity squared. And I'm plugging 0 into that. So we have 2 times 0 minus 1 is negative 1, 0 plus 1 is positive 1. 2 over 0 plus 1 is 1 squared. So you get 2 times -1 times 2, which is -4. Altogether, y minus y1 equals m times x minus x1. y1 is 1, m is -4, x1 is 0. So this becomes -4x plus 1. And that one's easy to solve for y, so I don't mind doing that. All right. I'm going to stand up and turn the lights on in my room because it's getting dark in my room. So hold on just 1 second. Okay. So there we go. For number 5, so find all x values on the curve. Wait, did I record? Yes. Find all x values on the curve f of x equals 2x cubed plus 11x squared minus 3x plus 2 such that the slope of the line tangent to f is 5. Slope of the line tangent to f is 5. That means we want the derivative to be equal to 5 because the derivative will give us the slope of the tangent line. So we need to find f prime of x and set it equal to 5 and solve. So f prime of x, just taking the derivative, 6x squared plus 22x minus 3. We set it equal to 5. So I'm going to subtract 5 on both sides and get 6x squared plus 22x minus 8 is equal to 0. I can factor out a 2. So I have 3x squared plus 11x minus 4. And then it's just your favorite method of factoring. I personally like the bottoms up method, so that's what I'm going to do over here. So for the bottoms up method, you're taking your 3 and multiplying by the 4 to get that -12, and you make it go away. Factoring this becomes x plus 12, x minus 1. Then you divide by the number you got rid of, which was the 3. And you simplify. X plus 4, x minus 1/3, and then if there's any denominators, you bring that bottom up. So x plus 4 times 3x minus 1, or your favorite method of factoring. I don't care, whatever your favorite method is. So that'll give me x equal to -4 and x equal to 1/3. You can always check these, right? You can plug those numbers back in to the derivative right here and double check that it gives you 5. So if you did f prime of -4, 6 times -4 squared plus 22 times -4 minus 3, plugging it in my calculator right now. So let's see, -4 squared, 2 minus 3. I get 5, which is perfect. And then f prime of 1/3. So 6 times 1/3 squared plus 22 times 1/3 minus 3. Just quickly doing it in my calculator just to be certain. And I have a syntax error somewhere. Okay. And I also get 5. And it just asked for the x values. So those are the x values, -4 and 1/3. All right, so here's number 6. You're given a table. You're supposed f and g are functions with the following information. Find the derivatives of the following functions at the designated x values. So you're going to find the derivative of this function at 1 and the derivative of this function at 0. So if y is equal to f of x over g of x plus 1, and we want to find y prime, this is going to require quotient rule. where f is f of x, so the derivative of f is f prime of x, and g is g of x plus 1, and the derivative of that, so the derivative of g is g prime, and the derivative of 1 is 0. So this will be f prime g minus g prime f all over g squared. F prime is f prime of x. G is g of x plus 1 minus g prime is g prime of x. F is f of x all over g of x plus 1 quantity squared. So that's the derivative. We now want to find the derivative at 1. So we have to plug 1 in to that function. So that's just replacing all the x's with 1. F prime of 1 from the table is negative 1/3. G of 1 is negative 4. G prime of 1 is negative 8/3. And f of 1 is 3. So we have negative 1/3 times negative 4 plus 1 minus negative 8/3 times 3 all over negative 4 plus 1 quantity squared. All right. So literally, you could just do your math on your calculator from here, which is what I'm going to do because I am lazy. Negative 1/3, also just because, it's long enough. Let's see, plus, that'll just be 8 over 3 squared is 9. Negative 3 squared is 9. So it comes out to be 1. Y prime of 1 is 1. All that work, very little answer, but that's the answer, 1. Whew. So there's that. For 6b, the function we have is h of x equals f of x plus g of x, and that's at x equals 0. So for this one, you're doing chain rule. So the derivative of the outside would just be f prime and leave the inside alone. So maybe I'll do this in color. This will help a little bit, I think. Maybe. So the derivative of the outside, f prime of x plus g of x, and then it's the derivative of the inside. So the derivative of x plus g of x. Derivative of x is 1. The derivative of g of x is g prime of x. We were asked to find this derivative at x equals 0. So we have h prime of 0, plugging in 0 for x, 0 plus g of 0, 1 plus g prime of 0. Simplifying a little bit, this is before we simplify, we can just kind of find some of these things. G of 0 is 1. And then g prime of 0 is 1/3. So we have f prime of 0 plus 1, which is 1, times 1 plus 1/3. F prime of 1, we already found right here. This is negative 1/3. So we have negative 1/3 times 1 plus 1/3 is 4/3. So 4/3 equals negative 4/9. So the key there is just understanding that it's chain rule. Understanding that it's chain rule, and then going through the steps. And plugging stuff in from the table. Okay, we're getting there. We're getting close, sort of. That's kind of a lie, but we're getting there. I do still think we'll be able to finish by 6. And like I said, at any time, you're free to go. You don't have to watch this whole thing. You don't have to stay here, although I do appreciate you guys being here. It's nice to not be doing it alone, so I do appreciate that. All right, for number 7, these are going to be definition of the derivative problems. So when the test asks you, and it will ask you, to use the definition of the derivative, if you do not use the definition of the derivative, you will get 0 points on the problem. So I'm going to write this, use the definition, and it has to say that. If it doesn't say to use the definition of the derivative, you do not do it. The only time you ever use the definition of the derivative is when it specifically says to use the definition of the derivative. So for part A, the function is f of x equals the square root of 3x minus 5. The definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Remembering to bring the limit down each time. Limit as h approaches 0. F of x plus h is replacing x with x plus h. So we have 3 times x plus h minus 5 minus the square root of 3x minus 5. That's just f of x all over h. This is going to, if you plug in 0 now, you're going to get 0 over 0. So this is going to be a conjugate problem. So you're multiplying by the conjugate of the radical part, which is the numerator in this case. In the numerator, that's going to cancel out the radicals because the middle terms are going to cancel completely. So you get 3 times x plus h minus 5 minus 3x minus 5. In the denominator, the h is still there, and don't forget to write that conjugate that you multiplied by. And parentheses, because that's important. Parentheses aren't required here because we were multiplying a fraction by a fraction, but when it's all in one fraction, those parentheses are important. So I am the world's laziest person, and for the denominator, I'm going to literally copy and paste this because I can't bear to write it again. That is the mood right now. I'm not going to write it again. For the numerator, you have 3x plus 3h minus 5 minus 3x plus 5. So these 3x's are going to cancel. These 5's are going to cancel. And at that point, you're left with a 3h over h. So now that you've gotten to this point and everything else is canceled, and there's just a 3h on top, those h's can cancel. So now on top you have a 3, and you have the square root of 3x plus h minus 5, square root, plus square root of 3x minus 5. Now that the h's have canceled, and this is always true with the definition of the derivative, now that the h's have canceled, you are good to plug in h equals 0. When you do that, you get rid of the limit sign. So you have 3 times x plus 0 minus 5 plus the square root of 3x minus 5, which is 3 over the square root of 3x minus 5 plus the square root of 3x minus 5, which you could leave it like that. That's fine. But really, you should simplify it because you can. Because there's 2 of them, it would become 2 square root 3x minus 5, and that would be your final answer. So that would be that guy. For 7b, also using the definition of the derivative. I'm not going to rewrite that direction, but it's using the definition of the derivative. So it's 2x over x plus 1. Finding y prime, this is the limit as h approaches 0 of f of x plus h minus f of x all over h. Right, so for f of x plus h, we have 2x plus h over x plus h plus 1 minus f of x is just 2x over x plus 1 all over h. To simplify our complex fraction, we are going to multiply by the least common denominator. That is going to give us, so we have 2x plus h. This guy's going to get an x plus, oops. Oh no, that was right. This guy gets an x plus 1 minus 2x, and this guy will get an x plus h plus 1. And then the denominator gets all types of stuff, x plus h plus 1 and an x plus 1. So I am going to FOIL. I'm going to FOIL this part first. So I have x squared plus xh plus h minus, and then I'm also distributing here. So minus 2x squared minus 2xh minus 2x all over h times x plus h plus 1 times x plus 1. And I'm lazy. I'm just going to distribute up here 2x squared plus 2x plus 2xh plus 2h is what this distributing would have been if you distributed the 2 to everything. And the 2x squareds would cancel. The 2xh's would cancel. The 2x's would cancel. You'd be left with 2h over h times x plus h plus 1 times x plus 1. Then the h's would cancel. And then you could plug in h equals 0. So you'd have x plus 0 plus 1. It's x plus 1. You would end up with 2 over x plus 1 squared. I'm just simplifying it because x plus 1 times x plus 1 is x plus 1 squared. So just saving the time of doing that. And, oof, okay. So we have an hour left of my 3 hours of talking about calculus. Trying to think of if we can get all this done. I don't know if we can. So I might end up skipping some of the stuff. I'm going to do this graph one, though. All right, so for the graph one, this is number 8. There's a few questions about it. So here's your graph of f, and you're asked, where is f discontinuous? Well, let's just, trace it and see where you have to pick up your pencil. So continuous, oh, here at -2. That's a problem. Continuous, oh, here at +2, that's a problem. And tracing, oh, here at, let's see, 3, 4, 5, 6. At 6, we also have a discontinuity. The next part is, where is it not differentiable? And for not differentiable, we are not differentiable at a few places. We're not differentiable at a discontinuity, at a cusp, or at a corner. So all of these values up here, because we're discontinuous there, all of those are going to be in our answer. So, I mean, we could put those in right away. We could say -2, 2, and 6 because we're discontinuous. Right here, this is a cusp. So we are not differentiable at a cusp. So -1, -2, -3, -4, -5. And then this right here is a corner at x equals 3. So we are not differentiable there because there's a corner. And everywhere else we are differentiable. So we're not differentiable at -2, 2, 6, -5, and 3. Part C is a tricky one. So part C is tricky because if you plug in h equals 0, you're going to get 0 over 0. It's not going to work. But what you'll notice is that this kind of looks like, oops, where's my pointer? This kind of looks like the definition of a derivative, right? The definition of a derivative is the limit as h approaches 0 of f prime of x plus h minus f prime of x, not prime, there's no primes there anywhere. This is f of x plus h minus f of x all over h. And that's interesting because what if we took this x right here and we made it into a 0? F of 0 is 2. So this would be the same thing as f of 0 plus h minus f of 0 is 2 over h, which, oops, with the limit part here, which is what's being asked for. So this x right here is actually a 0. This question is asking, what is f prime of 0? So it's asking what f prime of 0 is in a tricky way. The derivative of the tangent line, if you have just a line here, it's just the slope of this line. The slope of this line. And you have 2 points. So you have this point -2, 1, and you have this point 2, 3. So if you're finding f prime of 0, y2 minus y1 over x2 minus x1, you're just finding the slope of a line. So this is 3 minus 1 over 2 minus -2. So 2 over 4, which is 1/2. This one's a tricky one, I'm not going to lie. C is the tricky problem here. Part D asks you to arrange from most negative to most positive these derivatives. So the slope of the tangent line at these points. So for f prime of -3 is right here. That tangent line looks like it has a slope of 0. So I think that f prime of -3 should be 0 because this tangent line appears to have a horizontal, it appears to be a horizontal tangent line, which means its slope is 0. F prime of 1. So 1 is right here. So we're talking about this point here. We already talked about the slope of this line, right? The slope of this line was 1/2. So f prime of 1 is 1/2. And then finally, f prime of 2.3. 2.3 is somewhere in this area, which means you're finding the slope of this section of the line. So this is 2, 1. This is 3, -2. So we have y2 minus y1 over x2 minus x1. y2 is -2 minus 1. x2 is 3 minus 2. So we have -3 over 1, which is -3. So the numbers that we're arranging are 0, 1/2, and -3. Oops, let's do that in blue. -3. From smallest to biggest. So the smallest number is f prime of 2.3. The next biggest number is f prime of -3. And then the biggest number is f prime of 1. So that's how you would arrange them. H is going to require a little bit of work. I don't even know if I want to do, not H, E. I don't even know if I want to, like, there's other things I want to kind of approach on here. So maybe I'll just kind of talk about what you would do rather than actually doing it. You have a function, you want to find the tangent line at this point. So you have x1, you have y1. And then to find this, you want to find h prime of 4. So you have to find h prime. H prime is going to require you doing quotient rule. So you would do quotient rule, f and g, and then you would find the tangent line using that. So you would find the slope of the tangent line there. So I'm going to skip that one because I want to make sure we get to other things, and that's what I'm going to do. So I was just talking without it recording. So I'm just going to do A for this one because this is already running a little long. It's 5:11 p.m. We have 50 minutes left and I want to get through some related rates problems. So I'm just going to do A because I think that'll be a good one to practice. So we're going to do implicit differentiation here. So we are differentiating both sides here. So we have x cosine of 2x plus 3y equals 1/3 y to the 1/3 sine x. We're going to have to do product rule. So we have f and g. So for f is x, f prime is 1. G is cosine of 2x plus 3y. G prime, the derivative of cosine is negative sine, and leave the inside alone. Then it's the derivative of the inside. The derivative of 2x is 2. The derivative of 3y is 3 dy dx. All right. Then we have f and g again because we have product rule over here that we have to do. So for f, we have y to the 1/3. F prime would be 1/3 y to the negative 2/3, and then because it's a y, it's dy dx. G is sine x, and the derivative of sine x is cosine x. So putting this all together, derivative of the left side, f prime g, so that'll just be cosine 2x plus 3y, because 1 times g, plus g prime f. So I'm going to do minus because sine, it's minus there. Well, no, it's fine. We'll do plus. G prime, negative sine, 2x plus 3y, 2 plus 3 dy dx. G prime, and then f is x, is equal to f prime, 1/3 y, negative 2/3 dy dx. F prime g is sine x, plus g prime cosine x times f, which is y to the 1/3. So it's a mess. I'm trying to decide the easiest way to do this. It's all going to be kind of gross here. We need to get the dy dx terms to the left side. Now, technically this whole thing has a dy dx in it, and I'm going to try to be tricky here. I'm going to let him stay. I'm going to take this term and I'm going to move him over because they have dy dx terms in them. This guy doesn't have a dy dx, so he's going to move to the right. And then this guy can stay because he has no dy dx terms and he's already over there. And apparently I have to move that up, move this up. Oops. Alrighty, tidy. So I'm going to move this x in front of here. So we have negative x sine of 2x plus 3y times 2 plus 3 dy dx minus 1/3 y to the negative 2/3 sine x dy dx. I am going to have to distribute that guy. I was hoping to get away without it, but I'm going to have to. Then we have y to the 1/3 cosine x minus cosine of 2x plus 3y. So unfortunately, I do have to distribute this guy because I need that dy dx by himself. I'm going to have to distribute and then move one of them over. I am very quickly running out of steam at this point. Give me a moment. I need to stretch and maybe beg my husband to bring me food. Hold on just a second. There we go. I didn't start recording. So anyways, I'm going to do this in 2 parts is what I was just saying before I started recording here. I'm going to finish up this problem, and then for the rest of the problems, I'm going to do them on a separate time, probably tomorrow, and post those as a separate video so that it's all there because I am out of steam at this point. So do this distribution, and nobody wants to hear somebody who's out of steam try to do a math review. It's just gonna get awful for everybody involved. So 3 minus 3x sine of 2x plus 3y dy dx minus 1/3 y to the negative 2/3 sine x dy dx So then the unfortunate thing is this guy needs to move over to the other side. And then I'm going to factor the dy dx out of both of these. I'm going to do that in one step. And I'll also do the rest of these problems. I'll do the rest of part 9 when I go to do the other video. That way you get a better explanation of part of implicit differentiation other than the one you're going to get right now, which is the best I can do. All right, so I'm factoring this dy dx out of these guys right here. Negative 3x sine of 2x plus 3y minus 1/3 y to the negative 2/3 sine x equals y to the 1/3 cosine x minus cosine of 2x plus 3y. And then don't forget, we moved this fella over, so that's plus 2x sine 2x plus 3y. This is a problem that just makes me say why. Why? This problem was originally of the author of the guided lecture notes doing. So it's a doozy. All right, y to the 1/3 cosine x minus cosine of 2x plus 3y plus 2x sine 2x plus 3y. I mean, I like doing calculus, but even this problem's a bit much for me. This one's a little bit on the this is a too much type problem. And bam, easy as 1, 2, 3. There's that derivative. And that's just by dividing by this guy here. So, like I said, I will do problems B and C for 9. I'll do 10, 11, 12, 13, 14, 15, 16 in a separate video, and I will post that probably tomorrow. I don't see myself sitting down for another hour tonight. So I'm going to stop that recording.